Hello, this video is going to cover the basic idea of polynomials and adding and subtracting them. So first of all, what is a polynomial? And I'm actually going to just show you the definition in the book and go over it. So we can see the definition right here. A polynomial in X is a term or finite sum of terms of the form ax to the n, where a is a real number and blah 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 is a whole number. Basically, all it is different numbers and with exponents and letters with exponents. So they give us these examples here. Okay, this first one's a polynomial. It has one term, so we call it actually a monomial. It doesn't have any plus or minus, so it's just a monomial or one term. It has a number, and it has some letters and some exponents. Okay, it could just be 12. That's still a monomial. Or it could be just x to the ninth. That's still a monomial. So let's look at a binomial. See, it has two terms. The first term is 3t. Okay, a number and a letter. The second term is a -5 or a constant of 5. Okay, so that is our second term there. Forgot to make that big. And then this next one here has three terms. 1, 2, 3 terms. And this first term here is 4m to the third. And then we have -5m squared and an 8. Okay, so each term is between a plus and minus sign. And if it has one term, we call it a monomial, two terms a binomial, three terms a trinomial, and beyond that we just start calling it a polynomial. Polynomial is like over all of them, right? So we have monomials, binomials, polynomials, trinomials. So anyway, then we have coefficients. So a coefficient is the number in front of any letter. So let's look at this trinomial. The coefficient of the first term is 4. The coefficient of the second term is -5. This is not a coefficient, it is a constant because it doesn't have a letter. Let's go back over to this first one, this binomial. There's one coefficient, and that's 3. Okay, so coefficient's a fancy word for the number in front of the letters. Okay, the degree of the term. So the degree of the term is the highest power when it's in descending order. It's the highest power. So when I look at a polynomial, make sure that the exponents are going down in descending order. So this goes third power, second power, no power, right? So what is the highest power? That is the degree of the polynomial. So the degree of this trinomial is 3. It's a third degree trinomial. What is the degree of this polynomial here? This degree is 1 because t only would have an exponent of 1. So the degree of this one is a 1. Let's look over at this little chart I have in the book here. Okay, so this chart, let me put it to where it's not kind of, that's pretty good. Okay, so here's a chart of different terms and the coefficient and the degree. So if we look at just 12x to the ninth, the coefficient's 12, the degree is 9. Okay, and if you look at 3x, we kind of looked at one like that. The coefficient's 3, degree is 1. What if you just have a number? Then your degree is 0. Okay, now let's look down at, do they have any better examples? Let me flip it over here. Are they okay? Here's the okay. So I'm going to look at 31. I don't care what the directions say. I'm going to look at A. What is the degree of this polynomial? Well, look at the term with the highest exponent on the letter. That happens to be the first one. It's in descending order. Sometimes they try to trick you. And that highest degree is 6. Okay, and so the degree of that polynomial is 6. What's the coefficient of the term with the highest degree? Would be a 5. I might ask you something like that. B, what's the degree on this polynomial? Well, see how this one's a 6, this one's a 5? 6 is still the highest, so that degree is 6. For C, the degree again is 6. For D, the degree again is 6. Okay, and that's because it wanted it in descending order in 6, but I wanted you to see that. All right. Then let's look at, so you have to, the degree actually tells us a lot about a polynomial, and I know it seems weird, like, how do you care about that highest exponent? But we care because it tells us a lot about the polynomial. Not that we've learned that yet, but we will eventually. Okay, so let's look at adding and subtracting, which is the main part of this section. Adding and subtracting polynomials. You've been doing this for a long time. So this idea starts in about grade 6 and works its way up to getting harder and harder and harder as you get through the college classes and then through high school classes. So let's look at my first example. So what if I have the polynomial 2x squared plus 3x minus 1, and I'd like to add that to the polynomial 4x squared minus 7x plus 3. So these are both trinomials and we are adding them together. I don't really need that parenthesis much when it's a plus, but we do that a lot. We say, okay, this polynomial plus this polynomial. So what we really want to do is see what common terms we have, like terms that we can add together. So these two both have a square. So you're going to combine those together. 2 of them and 4 of them make 6x squareds. Okay, so I've combined that one and that one. Look at the x terms. I have 3 minus 7, or 3 plus a negative 7. So you end up with subtracting those and getting a negative 4 x's. Negative 1, the last thing, plus 3 would give us a positive 2. And so that's my final answer there. Okay, what if these polynomials were subtracted? Same ones. What if I want to subtract those? Okay, well then I'm going to take this one minus this one minus this one, and so forth. A lot of people mess up these signs. So what I teach is let's write it as an addition problem and then do it. So you could do it this way. If you can think of this negative minus 7 as a plus really easily, you're not going to need to rewrite it. If you can't think of that, here's a better way. Change this to plus. Change the sign of each term. And I did that in red so we could see that I changed this to be a plus sign and then the sign of each term. Now I can just add and combine them, and it's a little easier to see where the negative goes. So negative, or 2x squared minus 4x squared would give me negative 2x squared. 3x plus 7x is going to give us 10x. Negative 1 plus negative 3 would give us negative 4. Okay, so be careful. Negative 1 plus negative 3 that you add them. Okay, go more into the negative. So definitely different answers between plus and minus, and you need to be careful with your minus, right? Then they just kind of do the same thing written in different ways for the rest of this section. So remember you can only add things with like terms. So let's do one more that kind of mixes it up on you. What if I have, okay, maybe I have 4a squared minus 3a plus 2. And I'd like to, I'm going to subtract again just because those ones are harder for a lot of people. What if I want to subtract off 2a to the 4th plus 2a, and that's it. So look at the difference between, first of all, the other two were both trinomials, and this one has a trinomial and a binomial. We still do it similar, but we want to be careful that we only combine the ones that have the exact same letter with the same exponent. So you can't combine an a to the fourth and an a squared. You can combine the a and the a, so we can only actually combine one term. We don't have another number, so we don't even have a number to combine. But let's change our signs, this to plus, minus, minus, and then let's combine what we can. We don't have an a squared to combine it with, so I'm just going to write that down. I don't have an a to the fourth to combine it with, so I'm going to write down the negative 2a to the fourth, and I've taken care of those two terms. I can combine these. Negative 3 plus 2 more negatives is going to make 5 negative a's, and then 2 doesn't have anything to combine with, so I keep the 2, and that's our final answer. I do want this typically in descending order, so I'd really like this one to be written first because it's got the highest exponent. So negative 2a to the fourth plus the next one would be 4a squared minus 5a plus 2. So some of your problems might ask for you to write it in descending order for the exponents. Some of them don't care, so just be careful of that when you type in your answers. All right, that's all of 5.2, combine like terms. Just be careful.